Hey, welcome back to Fully Defined. My name's Chris. This is the Build and Learn series where Lego builds and SolidWorks skills come together. This is our second episode on the roof subassembly. Here we're finishing off the remaining parts, and probably the most interesting part of this lesson is where we look at some advanced mates to get the roof connected to the main body of the buggy. As we go through that process, we can see, again, some things that are just a little bit off, and so we'd make some tweaks in the assembly. The end result, if you followed along and you're getting to this point, you should be very pleased when you see just how close we can get from modeling things to having that roof nice and straight and lined up. Hope you enjoy. Let's go. All right, next one. The next part we've got is the modified 1x1 with the open O-clip. Now we've already got one of those parts used here. This is the 1x2 version. I believe we can probably change to a config. Oh, it's 2x. So it's 2x, etc. But we can probably change this very easily to make it a 1x. In fact, I think that's probably what it's got here. If we rename this, can't rename that one, but another one we can create, we can go 1x1 down there. And for the 1x1, what are we going to do? We can cut. Let's do a cut extrude in the top plane. And let's just measure that to make sure we get to 7.8. Number lock on. Okay. Extrude through all, flip side to cut. No, sorry, wrong side. Don't need to do that. And I want to go the other direction. Up. Now, we need to roll this back a little bit before the shell. So, go ahead and do that. In fact, we're going to have to do it the old way, which is here. So let's, we've got front plane. Let's just do it a different way. We do cut with surface. And we just want to measure 7.9, 7.8. So this one is 3.9 to that side, 4 to this side, which means we're going to move it 0.1 in on this face. Okay. Shell can go ahead, cut the wrong side. Easy mistake to make. Let's flip this surface cut. Let's edit this move face to here. Let's check the dimension. So beautiful. Shell. And then we can do our shape there. Let me just check the part that has that detail. If we have a look at, I have to pull the actual part off. No, underneath it's actually a little bit different. It's just got the square cut. So we suppress it in this configuration. The delete face works. We keep that. It's cut down. It is a little bit shorter. And then this all remains, should be pretty much the same. I think it's just lost a reference 10-degree angle. So if we just change that 10-degree angle to be off like the top plane, for instance, then it won't lose that reference. That plane will remain there. Okay, that's looking good. That's good as well. So that is in the middle, small fillet, and the cut extrude is the last little detail it needs, and that looks great. So we have a modified with an open O-clip, a 1x1 version. Let's just check the 2x1 still works, which it does. So we can save that, go back to our assembly, and then make a copy of that part and drag it over. And as a copy, I'm going to click here and change to the 1x1 configuration. And there we go. Let's assemble those. How they're assembled is, you can see the dot is actually going onto the bottom, and then the clip goes onto that round. So we're going to have this face on this one, this face on this. Now, there's no other circular mates here. So to make these two and get them aligned properly, we're actually going to go into that part file and find this boss extrude and just show that sketch, because what we can do is align this circle to this circle and lock rotation, and that's going to stop it from rotating as well. So that part is now fully defined onto this. Now we want to do another copy of those. We're not going to worry about mirroring. We're just going to make duplicates and get them to mate. Now these parts are black. You get them both black, and we'll get both of the other parts yellow. Then we add our mates using our face. And then once again, we just want to show that sketch. And I can show it here, and it's going to show it for both files at the same time. You can see that. Same part, so anything you show or hide in one of those parts will show in the other one. We're using this one, and I want to lock rotation. Cool. Now I can hide that sketch. It's hidden for both. All right, so let's move these together. We obviously want to get them to fit. Let's line up the outside face of the parts, and we can see there still remains gaps there. So that's good. And we can just rotate that up a little bit, and that's done. Very nice. Okay, and the next part we have here, two of these clippy looking things. We look to the part name. They are a black bar holder with clip. Now that clip detail looks very, very close to clip detail on the other part that we just did, the open O clip. I would expect that they're actually the same. So what we can do is, let's open this one as the 1x1 version. And for this part, which is called a bar holder with clip, we just need to add that new shape on the bottom and that hole and delete the rest. And so we're going to save this as new name, bar holder with clip, delete the unused configurations just to clean up the file, and then we'll get to editing in a sec. Okay, so we've made it 7.8 by 7.8. I actually don't need a flat, but what we do want is a different shape. So let's edit this sketch and we'll measure that shape and draw what's needed. Now it's a flat on one side, which is 5, and then a round on the other side, which is like 5.2. So quite interesting. Let's flats and rounds, and I think it's this one that needs to be bigger, 5.2. Yeah, so it's very small flat sections, but they are there. Let's just measure again, 5.4, and then these actually are a bit taller, 7.8. Now the part is shelled, but it's not consistent, so we'll get rid of the shell feature as well. Instead, what it has is a round hole on the bottom, the normal size, 3.2, and I don't know if we can actually measure the depth of that. It's so small. If we go offset from surface 1.2, that'll be a pretty good guide. We don't need to cut. What we want now is our boss extrude. Now it's on the right plane. What we're going to do is change it to a mid plane, remove the offset of the feature, and then we're going to update the sketch. So most of the details should remain. The vertical relation, that distance relation need to change. I want to do it in a way that doesn't actually change the geometry of the part. So we can do it like that, vertical. Now the full height of the part, 13.8, all right? And then it has a flat section which joins down with everything else. So we'll measure and put that in. It's 3.2. So somehow they got in line with those points, which is not necessarily correct. To change that and make sure that, what do we have to do here? Get the height of this correct position. Just going to accept that sketch. Go back to the previous part just to find a reference for that height using 4.2 from the bottom, 3 millimeters from the top. That's the one we need. So from bottom of this to here and drag that out. Let's try again because I'm trying to get to the bottom of it. That is being difficult. Let's just draw a construction line, 3.2. Nice. Save. Edit the sketch plane. It's just lost the face. Put that back in. We can also delete the other configurations, add a new configuration, which is default. Delete the current one. Roll back down. And we can see we don't need these fillets and we don't need this last cut extrude. That's all done. The part's done. Let's put it in the assembly. Okay, so we go to our assembly. I get an insert component and these parts are getting clipped onto the front. So you can see here, and then we're going to do some assembly work. Here's a black part. We're going to make those. And now here's a new mate I'm going to show you. It's called a width mate. Basically, I'm going to select 2 faces on the outside and then 2 faces on the inside. So I've selected 4 faces. I'm going to hit mate. SolidWorks knows with that selection to automatically go to an advanced width selection mate where the constraint is centered. I'm going to press OK. You can see it's lined up that part perfectly in the middle of what it's clipping onto. Repeat the process on this side. 1, 2, 3, 4, mate. And the other thing we'll do is just line up these faces with a standard coincident mate, which means you rotate one, they'll rotate together. All right, this little detail of our buggy is now complete. We can close this file. In fact, we can close a couple of files, this one and this one. Look at our assembly instructions. Here, we're now, with those parts clicked on, we're actually going to join the whole thing to the main body of the buggy. So let's go through that process. Now, somewhere here, this part here was fixed, so we have to float that one. Okay. Now the steps that we've just done are all in the 50s. So all these parts, we're going to add to a new folder, steps 50 to 59. Now we're going to bring that whole assembly up to the middle and we're going to mate this circular face to this circular face here with a concentric mate. Now we need to get it in the middle. To do that, we can use the trick that I just showed you before. For that, I'm going to select this face and this face as my 2 outside ones, and then this and this as my 2 inside faces. So the order of selections does matter. You can see where they get put in there. And now that is perfectly in the center of our assembly. The next step we need to line up these ones. Now these have a pin size of 3 and a hole of 3.2. So we're going to grab the mate tool. I'm going to grab that inner face and this outer face and make them coincident. Now, they do not want to be coincident at this point. So we have work to do. Sometimes it can just be that they need a little bit of rotation because both this one and this one can rotate. So there's no problem with that. But if you missed it, I'll show you again here. It's actually not the fact that they can rotate being the issue. It's the fact that they're in different positions. Okay, so this one, it's a little bit off center. So somewhere along the way, once again, we have some dimension issues that need to be identified and then corrected. All right, so first thing I'm going to do is actually grab these two faces and make them parallel. And that is at least going to line up those faces. Next, I'm going to grab this part and I can see the top plane through that part. And then this part here, just going to show some planes. Top plane is not the right one. Should be a right plane. So I'm going to show that right plane, hide the right plane of the assembly. I'm looking at this part here and I'm going to show the right plane for that part. Okay. And now I can measure between those two. See, it's a pretty small difference, but I can select them, 1, 2, and it tells me that they're 0.3 millimeters apart. So we have a few options. First option we can check, can this one slide? You can see in the design of this part, it can actually slide side to side. What is the clearance? Well, the clearance is between this face and this face. You can see here, distance is 0.03. Sorry, 0.3, which means I could edit the mate on this part and it would have enough room to move. And that's the easiest and most obvious solution here. So I'm not going to go through all the other potential options. We're going to use that. So to fix that, I'm going to go click on this part. Up here, I can see the mates associated. I'm going to edit this width mate. And where before we had this width mate and the constraint being centered, you can see it here. If we change that to free, press OK, that now means this part can slide side to side. And so look at that again. This one can slide side to side. Now we need to do the same thing for the mate on the other side. So I'm going to edit that one as well and change that to free. Okay. And then I'm going to bring these back up. And now let's try that coincident mate again. So I'm going to delete, what mate did we do? This parallel one. I'm going to delete that. And I'm going to try for a concentric mate on this face to this hole. You can see that works. I'll do the same on this side, but not axis, no. Face, concentric, yes. All right. And now next step, this face to this face here. Done. And if we just take a step back and look at our side view of our part, that looks really good. That looks nearly perfectly horizontal. And I'm talking about this face at the top. So if I actually measure that, you can see it's less than 0.4 of a degree off perfectly horizontal. Now, I'm sure Lego designed it to be horizontal with perfect fitting. To be that close, that's really cool. Now, so if I'm fit together the real model, I can notice a few things with those parts. The round parts are actually the same diameter on the outside. So where I had this one here at 5.8, I'm just going to increase the size of this one to match 5.4. Let's just bump that up. Better? Okay. And we'll save that. And that, we are getting closer to the final thing. Nearly there. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the Lego Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.